We're going to talk about some examples of biconditional statements right now. But before we do that, I'm going to give you a riddle or a joke. And I'll tell you the answer at the end. Why was the math book sad? Discuss. All right, so here we go. Write the conditional statement and the converse within each binomial. And that's important because we know that a biconditional statement combines the conditional statement and the converse. So here we go. An angle is obtuse if and only if its measure is greater than 90 degrees and less than 180 degrees. All right, so the conditional in this is if an angle is obtuse, then its measure is greater than 90 degrees and less than 180 degrees. The converse would be if an angle has a measure of greater than 90 degrees and less than 180 degrees, then it is obtuse. It's probably very exciting. I should probably type it up, but I don't feel like typing that much. Oh well. So I'll say that again. The conditional is if an angle is obtuse, then its measures would be greater than 90 degrees and less than 180 degrees. For our next one, a solution is neutral if and only if its pH is 7. Right? And I remember I used to manage a pool and I always have to measure the pH balance of the pool, make sure it's within reasonable limits so that it was safe for the public. So the conditional in that case would be if a solution is natural or neutral, then its pH is 7. The converse is if the pH of a solution is 7, then it is neutral. It is neither basic nor acidic. All right, so our next question, for each conditional, write the converse and a biconditional statement. So here we have, if 5x minus 8 is equal to 37, then x equals 9. Let's just double check it. 9 times 5 is 45. 45 minus 8 is 37, so we know this is a true statement. So we're to write the converse and a biconditional statement. All right, so let's go for the converse. So if x equals 9, then 5x minus 8 must equal 37. So we start with the end, begin, and end with the beginning. So our biconditional statement would be 5x minus 8 equals 37 if and only if x equals 9. Fairly straightforward. Determine if each biconditional is true. If it is false, give a counterexample. All right, so we have a rectangle has side lengths of 12 centimeters and 25 centimeters. If and only if the area is 300. Well, if we multiply 12 times 25, lo and behold, we will I got distracted, I'm sorry. So pulling up a calculator. All right, so let's do 12 times 25, and lo and behold, we get 300 centimeters. Now, you need to be quiet, buddy. Now, that clearly is true, that a 12 centimeter by 25 centimeter rectangle does have an area of 300 meters. But remember, for it to be a biconditional statement, we have to be able to take the converse and it would still have to be true. So the converse would say a rectangle of 300 centimeters squared, or of area of 300 centimeters squared, must have side lengths of 12 and 25. But wait a second, I could also go 10 by 30, and I would still have a rectangle of area of 300 centimeters. So this is not true because the converse is not true. All right, a natural number n is odd if and only if n squared is odd. Well, let's think about this. The converse would be n squared is odd if and only if a natural number, or n is a natural number. So is that true? Well, yes, that is true. So we're good. Finally, why is it necessary to be able to write a definition as a biconditional statement? Geez. Well, let's see. A definition is a statement that describes a mathematical object and can be written as a true biconditional. So, why is it necessary to write a definition as a biconditional statement? Well, because most definitions in the glossary are not written as biconditional statements, but they can be. The if and only if is implied. All right. When is a biconditional statement true? A biconditional statement is true if and only if the conditional statement and the converse are both true. All right. So here's what we have for your book work. So we have 11 through 31 odd, and 37 and 46 through 48. Now on these, this is not something we did a whole lot of last year. And this is having to do with parent functions and moving a graph along a grid. So feel free to use Desmos, and please remember the parent function for a quadratic is simply y equals x squared. Let's make that look better, x squared. And finally, the answer to the joke. Why was the math book sad? Well, it had too many problems. Ha! That's almost as good as Miss Hatchett's morning announcements joke. If you have any questions, please come over to Math Fun, and I'll be happy to help you.